I'm here to assist you with all your test equipment needs, from multimeters and test weights to patient simulators and X-ray analyzers. If you need guidance or you have any questions, please don't hesitate to write me at jbarber@bcgroupinternational.com.
What's up, everyone? Welcome back to Better Biomed. Today, I'm going to show you guys how to use a multimeter to find a pinout, and that's exactly what we're going to do for this Vacmaster VP120. It's got these membrane buttons here, and those connect to these carbon trace leads right there that go down to this board. And what I'm going to do is I'm going to show you how to find common and then how to use your multimeter to pin it out. So let's do it. Now, the first thing you want to do is you can see I have this ribbon cable partially pulled back, and that is so that I have just enough access to get this little clip right here on one of the leads. There you go. Still connecting every single one of the terminals. It's just maybe not the best connection, but they're definitely touching. And what I'm going to do now is I'm going to take a look at the PCB. What we have to do is we have to find common, because the way that these buttons work is that there is a negative that is going to be sitting there, and then when you close the button, it's going to return a negative back here to the control board, and a pin that normally sits high is now going to be switched low because you're bringing that negative back to the pin. And that's how these control panels work. It's not that they have a positive like you would find in a power switch. It's a negative that's down here. So the pin has got resistors down here at the microprocessor, and it throws the pin high. So you'll see 5 volts sitting there on the pin, but on your common here, you've got a negative. So common's coming up here to like a spider web that's sitting behind this membrane. You can kind of see a little bit of it right there. You see how it spider webs out? And you're going to find this on almost every single membrane. There's going to be one common, and then all these here are going to be in a matrix for returning the negative back to the CPU. So what we're going to do is take a look at the PCB, and I want you to take a look really closely at this pin right here. Now, all these other pins, notice how each and every one of these pins right here is not connected to the ground plane. This right here is the ground plane of the PCB. So it goes all the way around the outside. Notice how this pin right here has got 2 tiny little traces. One of them right there at the top, one of them right here to the right. And that brings the ground from your PCB up here to the control panel. So what we want to do is, since we found the ground, we're going to connect our meter lead onto that, and then we're going to switch the meter to continuity. Now, you have to watch the display. Even though it's on continuity, a good share of these membrane buttons right here are going to be reading like 50 or 60 ohms. And because of that, you're not going to get a true beep-to-beep over here. However, it will still show you the resistance on the display. Some of the buttons, if there's a real good contact, they will actually bring it all the way back and show continuity. But most of them are going to be sitting around 50 or 60 ohms. So you won't get an audible tone. But what I do is I push down on one of the buttons. So let's start with the on and off. And then you go through each and every one of these terminals while you're looking at your multimeter, and you will either get that kind of tone, or you'll see some numbers up here. If you see some numbers up there, check the rest of the terminals, and the terminal that's got the lowest resistance is actually the pin for that function. So this one right here was my pin for power. This one right here was my pin for start. And then I've got lid up and lid down right here. And I found those. Now, I don't currently have seal mapped out to anything, so I'm not really worried about that. But what I'm going to do now is I'm going to solder wires to these pins right here. And then I'm going to plug it all the way in. And that is going to control my Arduino, which is now completely encased in hot glue. It's basically hermetically sealed. And you can see right here on my relays, those ones there are also locked in. Those wires are absolutely going nowhere. but this one here is going to be protected. The only thing now we have to worry about is our relays. They are going to be open bottom. So we have to find a material kind of like the silicone mat right here. And then we are going to mount it inside the vacuum system. So this is the inside of the vacuum. You can see I have an AC motor, and right here's a start-stop capacitor. And down here's my power supply. And there's some interesting things going on with this power supply. So right here, I've got 120 volts coming in. And then look at this. Right next to it is red and black. Now, you might be thinking that that's DC. Do not make that mistake. This is also an AC. They're actually running in parallel. And what used to happen is that one there used to go to this control board right here where it would switch AC on and off for this guy. Now, I'm currently unaware. You can see where it blew up right there. It poppity popped right in my face. Not good stuff. But I'm currently unaware if these guys right here, let's see, I didn't even look at them. Oh, they're all 12 volt. Cool. So these are 12 volt. This motor right here clearly says 12 volt. I dig that. Now, the only thing that's in question is the heating element, which that's this guy right here. And there are no indicators on this. Now, normally heating elements run off of AC. However, I do not know if that is how it is routed through this. So it says right here, heater plus and heater minus, which is maybe a little confusing. So I've got to map that guy out just to be sure. But yeah, you can see it popped a capacitor right there. And thus, this board right here is probably fragged. Something else is going on with it. It's not just that capacitor, but it also fragged the inside of my control panel right here. And I want you guys to take a look right there. You guys see it? Right over here. So it popped one of those guys as well. So I have got some freak voltages, which is why I said go ahead and screw it. We're going to go ahead and create our own brain box, write the code. We're going to get rid of this little microcontroller. This guy here, I did verify it's got 12 volts coming out. So that's kind of cool. We got 12 volts coming out of it right here on that side, and it's nice and stable. So I've got my 12 volts for switching, and I've got my 120 volts, which is going to run up here to my relays, and then they'll be switched on and off. So the only thing I got to figure out is that ceiling bar. When I figure out the ceiling bar, then I will know the rest of the pins and what I got to do. But so far, so good, guys. It's going to be good. So anyway, that's just another video in the step-by-step process. I know I was going to document this thoroughly. Normally, I just want to hurry up and get the work done. And unfortunately, you guys miss out on some really good content when I do that. So this time here, I said, you know something? I'm going to take the extra step, and I'm going to show you guys step by step, regardless of how stupid it may seem, of how I do what I'm going to do. So next, we're going to go ahead and we're going to do some digging on that AC, possibly AC. There's no way it could use 12 volts for heating, right? That would just seem to draw a lot of amps. So you'd think it's switching AC. We're going to figure that out. But then the brain box is going to get wired in there, and then we'll fire it up and test it out now that I know the pinout for my control panel. Thanks for watching, guys. Hope you like these kind of videos. If you do, please give me a thumbs up. I do appreciate it. Thanks for watching, guys.
If you enjoyed this video, don't forget to give it a thumbs up and subscribe for more content. I'd love to hear your thoughts, so drop a comment below with what you'd like to see in future videos.